proceed. In chapter 3, it's about graphing. 3.1 is about graphing in rectangular coordinates. Rectangular coordinates are also known as Cartesian coordinates. It's named after René Descartes, the French philosopher who revived this system of describing points. Actually, the Greeks had something like this long before, but they didn't have really very good arithmetic. They didn't have the number 0. So they never really pushed it. But René had the tools and used it. The idea of rectangular or Cartesian coordinates is to name a point in the plane by means of a pair of numbers. We start with a plane, and we draw 2 lines on it at right angles. The horizontal one we'll call the x-axis. The vertical one we'll call the y-axis. Right angles. At any point, and you center it at some arbitrarily chosen point called the origin. Now, if P is some other point in the plane, you can draw this rectangle by dropping perpendiculars to the x and y axes. That way we get a rectangle, therefore the name rectangular coordinates. Since it's a rectangle, these 2 opposite sides are the same, and these 2 opposite sides are the same. We'll call this x, we'll call these y. X is positive if P is to the right, negative if it's to the left. Y is positive if P is above, negative if P is below. And we'll say that the coordinates of P are this, x by y. It's a bit unfortunate that this notation is the same as the notation as the open interval from x to y. A notation collision, a little unfortunate, but here we go. The idea is that for every point in the plane, we will associate a pair of numbers, an ordered pair of numbers. This means that basically we can map between geometry and arithmetic. And that's always gives a good way to give a perspective on things, to see it in 2 different ways. So here are some examples. This point here at the center, called the origin point, is at 0 by 0. This point here, over 2 and up 1, is at 2 by 1. This point here, back 2 and up 1, is at negative 2 by 1. This point here, back 2 and down 1, is at negative 2 by negative 1. This point here, at over 2 and down 1, is at 2 by negative 1. All these points on the x-axis have a y value, y coordinate of 0. So here's negative 2 by 0, negative 1 by 0, 0 by 0, 1 by 0, and 2 by 0. All these points on the y-axis have an x value, x coordinate of 0. So here's 0 by negative 1, 0 by 0, and 0 by 1. Now, these two lines divide the plane into 4 quadrants. In this quadrant, upper right, the x values and the y values are both positive. That's quadrant 1. Here in quadrant 2, the x value is negative, and the y value is positive. Negative by plus is quadrant 2. Down here in quadrant 3, both x and y coordinates are negative. And over here in quadrant 4, the x values are positive, the y values are negative, plus by negative. And anywhere on this x-axis, x could be any number, but y must be 0 here. And anywhere on the y-axis, x is 0, but y could be any number. So 0 by whatever. Now, if we have an equation, y equals constant. What's constant on a horizontal line? On the x-axis, here, y is 0 for every point. If the y equals 1 corresponds to all the points here on the, where you basically raise the x-axis 1 unit, like this. Here's the y equals 1 line. Y equals negative 1 corresponds to all the points here on this, on this line where we take the x-axis and lower it by 1. So x equals constant corresponds to a horizontal line. Y equals constant on a vertical line. On this y-axis, x is always 0. X equals 1 on every point on this vertical line. X equals 2 on every point on this vertical line. X equals negative 2 on this point on this vertical line, and so on. All right, so we have some examples from the book. Here we go. Get asked to plot some points. -3 by 4, 4 by 3.5, -2 by -5 halves, 0 by -4, 3 halves by 0, and 2.7 by -4.1. -3 by 4 is back 3 and up 4 here. 4 by 3.5 is over 1, 2, 3, 4, and up 1, 2, 3 and a half here. -2 by -5 halves is back 2, left 2, and down -5 halves, and it was down 2 and a half, 1, 2 and a half here. 0 by 4. 0 means that it's x is 0, it must be on the y-axis. -4, you go down 1, 2, 3, -4, and here is that point. This E is point E is 3 halves by 0, so it's 1 and a half, 3 halves over, and on the x-axis here. And finally, 2.7 by -4.1 is over 1, 2.7 roughly here, and now -4.1 roughly about here. I think my drawing was a little inaccurate, but there that is. Now here we go the other way around. A, B, C, D, E, what are their coordinates? This one on the y-axis, so x is 0, up 1, 2, 3, 4. So A is at 0 by 4. This point here is over 1, 2, 3, 4, and up 1, 2, 3. It's at 4 by 3. Here, 1, 2, 3, 4, -5. X is -5. Since it's on the x-axis, y is 0. -5 by 0. This point here is back 1, 2, 3, 4, and down 1, 2, 3, 4, 5 actually. So it's -4 by -5. And this point here is over 1, 2, 3, and down 1, 2, 3. So it's at 3 by -3. Excuse me. Now this one that's trying to do what they call plotting a graph. The idea is that here we have time versus heart rate. Somebody's exercising 10, 20, 30, 40, 50, 60 minutes pass. So this axis corresponds to time passed. And this is beats per minute. I guess they're connected to some kind of measuring device. At time 0, 6 beats per minute. After 10 minutes exercising, it rises to 140 beats per minute. It stays constant at 140 till minute 40. And then cooling off the next 20 minutes, cools down from 140 back to 60 beats per minute. The question is, when was the heart rate at 100 beats per minute? Well, here's 100. So we find it happens here, it happens here, and this happens down here at 5 minutes. This happens here at 50 minutes. The answer is at 5 minutes and 50 minutes. The one like it in the book is a little bit better drawn, so by using, I guess, a ruler and so on, you could be able to answer it yourself. For number 37, they have 3 corners of a right triangle at -1 by -7 here, at -5 by -7 here, at -5 by -2 here. Now it's a right triangle because this is vertical and this is horizontal, so it's a right triangle. And they want to find the area. Okay, well, this is a right triangle, half of a rectangle. So the area is 1/2 of base times height. This. The base, well, it's supposed to be -5 and -1, that's 4 units. The height is going from -7 to -2, that's 5 units. So the area is 1/2 base times height. It's a half times 5 times 4 makes 10. Well, I believe that concludes that. Let me tell the robot to shut up. Stop recording.